This video shows you how to use the 16x52 high definition optical day and night vision monocular hunting, camping and hiking telescope. Here we will be zooming out and in on objects at a distance. Pretty much testing the object length and magnification to see if it provides a clear and bright image from a distance. So we will be zooming out at 2 points of interest. The first being the basketball court, and the second being where you've got a smorgasbord or myriad of cars packed, at a location. Do note that the field of view that you see here is from a standard camera lens and not the actual telescope that we will be performing a test run on. Suffice to say, it is representative of your naked eye. Do not use the telescope in a way that would amount to harassment under the Protection from Harassment Act 1997, so use it with consideration and spatial awareness of the objects in the space around you and also the awareness of your body position in that space. In terms of the functionality capabilities, it's got a day and night field visual angle. Here, the 16 strength magnification can be varied on a 52mm object length diameter. This enables your major focus on the eyepiece that you've got at the back. It comes equipped with a BAK4 prism and a fully multi-coated lens, that guarantees superior light transmission and brightness. A light transmittance of 99.5%, so that would probably give you an amazing viewing experience. The other focus on the smaller diameter of the telescope helps you to refine the image more clearly. You can make refined adjustments when you're viewing, through the optical lens. And so now that we're conversant with the core functionality capabilities of the telescope, we will be taking this telescope out for a test run, just probably viewing, outdoor to see what the magnification is like when you zoom out, through the optics. You really shouldn't worry about that because this is a high definition waterproof monocular with a built-in lens dust cover and an O-ring sealed optics, which helps to prevent the lens from dust, moisture, debris, and ensures that the living waterproof function is fit for most of the weather and environment. It can be quite an upheaval or daunting task, getting the telescope to stabilize whilst viewing from the optics. Using your mobile phone's camera to view through the optic lens would be more like having an albatross around your neck. As you can see here, I can barely get, the phone's camera to stabilize through both lenses, and that's because you need stability when trying to focus on an image. So let's think about what we're doing. If we observe the circus clown when juggling balls in a circus, he definitely needs control and stability to juggle them balls in the air. And this is what a tripod stand provides. But if you look at the construction or design of this telescope, it's got a spherical diameter, and so this would necessarily not fit in onto your conventional tripod stand. You will need a dedicated tripod stand for this. And so let's improvise. Let's try to simulate control and stability with whatever we've got, within the property and within your reach or control, as it would be virtually almost impossible to get, your phone's camera and the telescope in a static position without wavering on your unsteady hands. You can view directly with your naked eye through the telescope. That's not a problem, as your body provides stability and control. But when you try to use your phone's camera, it would be a challenging feat to achieve this, okay? So, what I'm trying to say is that looking through the telescope directly with your naked eye is pretty straightforward, but when you want to record what you're seeing through the telescope with your phone's camera or whatever camera, it becomes quite a challenging task. So, to negate the effect of the control that we do not have, we place the telescope between layers of the Venetian blind. But remember, on a tripod stand, you can have rotational movement in a circular motion or in an up and down motion. So you might still have to deal with the reflections, from the sun. Even if the back 4 prism in the telescope, has a higher refractive index, okay, you will still have to deal with the effects of the sun. Just keep taking it one step down the Venetian blinds until the reflections of the sun is mitigated, and try to record through the telescope. You can see we're getting some measure of control, but not necessarily the stability that we so desire. But at this point, you can begin to see that the telescope can, be used to view any static or moving object, okay? Provided you've got the stability and control that you so desire. And in this case, we are viewing the basketball court. This is the naked eye view of the basketball court. And when we magnify with the telescope, we can see that the basketball rim is magnified, okay? We can clearly see the arena, and the object or the basketball court appears quite closer when we zoom out of or tilt the focus of the telescope. So we've definitely got some measure of control. The basketball court is magnified. You can see the birds there, which you wouldn't necessarily see from a distance, but we haven't achieved the stability that we so desire. In order to reduce the strobe effect of the sun, you can pull on this cord here, which takes the telescope in an upwards or downwards direction, or the 12 and 6 o'clock position. And you can tilt the telescope to the 9 and 3 o'clock position, or westwards and eastwards, if you want to look at objects at the farthest left or at the farthest right, okay? And to provide more stability to the telescope when using our phone's camera or our Canon camera, I would position my elbow on the window sill to provide that stability for the phone's camera when recording. Having exercised control using the Venetian blind and stability using our elbow, and simultaneously adjusting the front focusing and the larger objective lens of the telescope, you can clearly see that we've achieved a broader zoomed out magnification of cars parked from a distance. If your object remains blurry, adjust, the large objective lens for as the main focus, and then for detailing, adjust the front focusing, and you should be fine, okay? And you can see that the monocular has got a large field of view. You can use it to enjoy bird watching, hunting, hiking, camping, and sightseeing. The list is endless. But just make sure that you're using it reasonably and responsibly in a way that doesn't infringe on people's personal spaces. Here we've got a naked eye view of the cars parked from a considerable distance, zoomed out, and when we zoom in on the cars parked from a considerable distance, we see that their image is magnified, okay? So we're using the 16 times magnification, and you can clearly see we've got, a better view, an enlarged image, okay? When we zoom in on them cars, you can repeat and reproduce the process for any object of interest by picking out your object of interest, exercising control and stability, and adjusting the focus. Subsequently, we will be making a comparison between the naked eye and the basketball court. So this is the zoomed out position, and when we zoom in, we see a magnified basketball court. Adjust the main object focus and the detailing focus, and you can clearly see the rim and the arena whiteboard, okay? As well as the strobe effect of the sun. So, adjusting the 12 and 6 o'clock position to negate that effect, okay? But you can still clearly see the basketball court, okay? If you're trying to record with your phone's camera or your device's camera, you can deploy the use of a tripod, where you would need an adjustable C-clamp connector to mount your telescope on your conventional tripod. Or you might be better off just investing in an astronomical spotting telescope with a smartphone adapter to record on your telescope, okay? The astronomical telescope most times are manufactured bespoke to the clamp you need to clamp them on the tripod, okay? So pretty much you can enjoy your scenery easily and rapidly by adjusting the eye cup and focus wheel until you see a clear and bright image. In conclusion, this monocular optical instrument has its own specific use and function that cannot be replaced depending on the activity you're engaged in. This single monocular telescope is an excellent choice for carrying binoculars, as it is half its size. It is smaller, more portable and lighter. It's got the portability advantage. It is small, light, can carry in your pocket and can be used for traveling. It's got the zoom in benefit. You can also use it to see things at a distance. So you can make detailed observations of objects at a distance, making it ideal for visualizing objects, animals, and even appreciating landscapes. The larger the magnification, the clearer the object will appear. So a 16 times will provide you 16 times macroscopic magnification. So an object at 160 yards away will appear through the lens at 10 yards away. The 16 times magnification allows you to capture spectacular images, to see distant peaks and amazing details. So it is used as a magnifying glass and it is cost effective. And that's about it really. If you found the information useful, don't forget to subscribe, like and share, helps the channel grow, and hopefully catch up with you later. Thank you for your time. Thank you for listening. Goodbye.